Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 25, we talk about the land price model. So, the different concepts that we will cover are the background of the study, the land use transportation context, supply and demand, land value theories, house price theories, hedonic regression analysis, and hedonic regression examples. So, basically in the last lecture we have talked about accessibility, which is one of the primary determinants for determining location choices or certain or the way people choose to both choose their residences or their locations and so on. And before that we have also discussed that both land prices and accessibility values are important to understand the way cities grow or the way people choose different locations in the cities and so on, and where real estate developers would like to build their housing complexes or commercial centers. All these things depends on the land price. So, we need to understand how land price or housing price or building price changes in an urban area, and that has to be tracked in an land use transportation model, so that we know that if any change in certain activities will result in change in the land price, and that will eventually again change in the other things like location choices or any kind of development choices by real estate developers and so on. So, it's a cyclic process. So, that's why we need to understand the way prices change in an urban area, or rather how to determine prices for different plots or buildings in an urban area. So, we know that housing is it's the largest share of household expenditure, and that also means that a change in housing prices may result in change in economic activity and may even lead to macroeconomic effects. That means housing play a very big role in the economy of a particular country as well. That means we have seen the subprime crisis that hit the world economy few years back. So, that was also related with housing prices, housing loan and so on. So, along with houses there exist not only housing prices, there is high correlation between land prices and house prices. That means when land prices increases, house price also increase and vice versa. So, land could be called as a heterogeneous good, and because it has got different characteristics and different uses, so we can call it a heterogeneous good. And appreciation and depreciation of land prices depend on many things. For example, there could be social issues, there could be economic issues, there could be legal issues, there could be environmental processes, and it can vary across different time periods. That means land price changes over time, and it can also vary over space. That means it can change over location as well. But change over time could be tracked by tracking the prices for a particular area, as well as what factors have changed during a particular period and how it has the land prices appreciated in a particular area. From there we can also track the increase of land price, and in terms of space, that we need to understand why land price, if a particular area in a particular point of time is different from another land price in another area, but in the same point of time. So, this could be also we need to understand these processes. And real estate and land valuation or appraisal is conducted before transaction, and this actually helps, like for example, before a real estate developer starts building or buying a plot of land, he does some valuation exercise to understand what could be the benefit of buying this particular land, what kind of returns he can get and so on, so that his decision is on a more solid footing. So for this kind of things, valuation software exists since 1970s. Initially it was land valuation softwares, and then for real estate. And land valuation transactions are, but even so, that means even so we have softwares, we have certain methodologies to understand what factors contribute to the land price before a transaction takes place. And we can say that even with all these techniques, land valuation transactions are very, very speculative in nature, which makes it very, very challenging to both study or to model. And there is also a lot lack of data of transactions and appraisals. So when if we have data on appraisals and all, then probably there is a chance that, okay, what were the things considered while the land price was decided or appraised, that if we have known those kind of data, then these are very location specific data, time specific data. If we have detailed data, then we could have done some form of models, but we don't have that kind of detailed data, because those transaction data are usually lost or are in private hands. So in the land use transportation context, when we have discussed urban simulation models or land use transportation integrated models, we have discussed urban sim, we can see the process flow of urban sim software. This we have discussed in previous lectures, and here you can see that in the entire land use transportation process, we have got over here accessibility. Like for example, travel demand, modal systems, these all influences accessibility. Accessibility influences economic and demographic transition models. It can influence many other things, residence and employment mobility locations, then residence and employment location choices, real estate development, then real estate development can influence land price. So, and land price again influences accessibility, or it can even generate different travel demands and so on. So, land price model, and then again there are land prices and accessibilities for particular areas, real estate vacancies, all these things are interrelated. That means whenever land price changes, that means it have an effect on accessibility, and when accessibility changes, it has got an effect on land price. So it's a cyclic process, we can call it, or there is a feedback loop in all this different components, like one influences another, but at the same time that when that thing gets changed, it will eventually influence the first thing that we started with. So how development projects, location, accessibility, etc. influence the price of land or real estate, which in turn helps us to understand the residential and commercial location choice decisions. So the different influence of this accessibility and land price, all this actually helps us to determine these location choices. And additionally, land price influence real estate development. That means real estate developers will buy land when land is cheap, or buy at a place where they can speculate that there the land price will appreciate with the introduction of certain infrastructure or certain other things. And this kind of decisions are influenced by land price on real estate development. And then supply and demand for land and real estate also determines land price and agricultural to urban conversion rates. So that means the amount of people coming into the city, that they will want to stay in certain areas, so that is demand, and based on that demand, real estate developers will start building houses, and that is the supply. So there is always a gap between supply and demand, and that also determines the land prices. If there is too much of a gap, like there is less supply, lot of demand, then land prices will appreciate, and vice versa. That means if there is lot of supply but no demand, land prices will fall down. And similarly, it will also have demand on the agricultural land to convert into urban land. So these are the two processes that go on simultaneously. So in economic models, when we talk about supply and demand, so there is this concept of equilibrium and disequilibrium. Now, when we do this land use transportation models, we have already discussed earlier that we can assume an equilibrium for a particular time period, or we can assume disequilibrium by not exactly disequilibrium, but equilibrium in small time frames. Like for every year, we determine what is the demand and supply in successive ways, and then we can also arrive at we can keep on estimating that. So that we can call disequilibrium. So, in equilibrium models, equilibrium refers to a hypothetical long-term market steady state condition, that is supply, demand and prices are perfectly balanced. That means at the end of the time period we will say based on the supply this is the demand, and this is and then these prices are mostly balanced, and buyers and sellers have full information about this prices and the benefits of the choices, and accordingly they will choose a certain location or buy a certain house or decide to build on a certain area and so on. Whereas in disequilibrium, supply and demand are not perfectly balanced, and responsiveness of agents may also vary. That means in housing, demand for housing may outpace or lag housing supply, causing disequilibrium, resulting in boom and bust cycles. So, in this particular image you can see this magenta is supply and gray is demand. So, demand is high, supply is less, then supply catches up, and then supply is more. So, here the price actually falls down because the supply is more in the market, then demand again gradually catches up, then no more real estate. When supply is more, then real estate construction actually subsides, not many people are constructing, then again demand is picking up, then when demand picks up, then again real estate construction starts. So, this time periods could be every year. This could be estimated that if there is a demand and bust. So, it doesn't mean that, like for here we can see this cycle going on for around 3 years. So, there is this is a cycle where actually the supply is more and then demand is less. So, that means this is a bust cycle. Then there is a boom cycle, is when there is lot of demand, there is no supply, supply is picking up, so prices appreciate. So, that is a boom cycle in that sense. So, since there may be substantial departure from equilibrium, that means there may be much demand gap in demand and supply. So, we need to understand that that what we should prioritize whenever the real estate developer will try to build somewhere. He will try to understand that which things people want, because everything cannot be provided because there is less demand. So, things which are more demanded, that should be provided, or wherever he can add certain things which may actually help him to get some earn more money, those things would be targeted. So, since so that is what needs to be understood, that which components of housing or land actually is generating more price in the market. Not all, because land is a heterogeneous good, and similarly housing could be also broken into many components. Not everything is demanded by the people. Not only certain components there would be higher demand, and that is for those components people will be willing to pay more. So, if market, so this is because of disequilibrium, these things we need to know. But if market was in equilibrium, we could have said that that means whenever we are supplying the supply, if market is in equilibrium, this would be equal to the supply price of adding an increment of that particular attribute. That means if I am if it's a balanced supply and demand, then what happens, then whatever I am supply, that becomes the price. That means if I am we are developing or providing a certain characteristics to a certain housing, and we are charging some extra price for it, that becomes the supply price, that becomes the price of that particular attribute. But because it is in disequilibrium, we cannot be sure that even if we add a certain price, that may not be appreciated in the market, that may not be what people want, that because there is disequilibrium. So, this is a concept that is being used. That's why we need to understand the prices of each individual component of either housing or even a land parcel. So, land value theories has been developed since the 1860s, and we have discussed this earlier. Von Thunen has said the price of land varies, or the value or farmland values are based on fertility, which is a physical characteristics, and market accessibility, which is a distance based characteristic. So maybe accessibility we can call it. So that means land value depends on its characteristics as well as its accessibility. And similarly, Alonso's bid rent theory, there the emphasis was on location of the land, and based on that location a rent gradient which declines from the distance from the central business district was proposed. That means the far away you go from the CBD, lesser would be the rent that you have to pay for a certain kind of land use, and that was the basic theory of Alonso's. And then these two theories were the starting point, but as you can understand there are a lot of limitations to these theories. So Rosen's theory proposed in 1974 proposed hedonic prices and implicit market theory, which actually talks about that value of a surrogate good or service is used to measure the implicit price of a non-market good. The example, willingness to pay extra for a house facing sea. That means a house is facing a sea, it's very difficult to measure that, but based on the amount of money which is people are willing to pay, we can, for this particular feature, then we can determine what is that price of that non-market good. So this is the first concept that started this hedonic pricing models or a hedonic regression theory. So property values can be attributed to features of the properties, and relative importance of these features can be explained through regression analysis. So because we know that for each non-market good, or what is the amount of price a person is willing to pay, so we can develop it for different components of the properties, and each of the attributes of the properties could be determined, and we can understand for which property people are willing to pay more. That is, the relative importance of the features could be determined, and that a real estate developer can also decide to supply as well. And this could be explained through regression analysis, and this talks about physical accessibility and environmental characteristics of that particular property, and this allows insight into consumers' preference and their willingness to pay for the components. That means the more this gives us an understanding that what people are willing to pay for. And hedonic price models reflect the outcome of the market equilibrium process and does not reflect the demand or supply dynamics of property market. So using this hedonic regression models, we can determine that if in case that means what is the components people are willing to pay and so on, but we are not able to understand that will it increase this, the supply, or what effect it will have on demand. So this kind of dynamics are not being able to be determined using hedonic models. So starting with land value theories, we can say that agricultural and urban land is measured differently. While agricultural land depends on the income potential, that means in future what kind of crops will grow in that particular land, or what kind of earnings could be gathered from there, where that is possible to be determined in case of agricultural land. But in urban land value determination, this is difficult, and usually we determine from the transaction data that is there in the available with us. That means what kind of price was determined for a particular land parcel in recent years when it changed hands. That data forms the base of understanding urban land values. So that is the difference. We can determine even for residential buildings, or like a real estate project or a commercial project or a mixed land use, that we can determine it based on an income based approach like that agricultural land, but it's difficult compared because we don't again have transaction data or appraisal data. So it's difficult to model or determine the income potential of land in urban area in that sense. So instead we go for a hedonic approach, which is more popular, where we can actually determine the components each contributing to that particular land price, and we can understand the prices people are willing to pay for that, and that actually forms the basis of this land value theories in urban areas. And land price data is collected from tax assessors record or actual real estate transactions. We get land price data of different plots or locations or housing at different areas from existing transaction data. And sometimes the number of transactions are not that high in a particular area. So to increase the sample size, we can take cross-sectional data on transaction for a period, maybe collected we can collect it, and parcel prices may be deflated to a base year for all samples. That means even though because land price changes over a time period, that means there may be significant change in land price from year A to year B, but because we are taking data for the period A to B, that means we have to bring all the prices to a common platform, and that is why we take the we deflate the land prices of years where land prices were high, and we deflate it to a base year for all samples, so that all data could be brought in the same baseline situation. And we cannot choose very long periods of data, because then even this we bring it to a baseline, there will be significant change in other characteristics which influence land price. So we basically are assuming that everything else more or less remaining same, what kind of price inflation or price increase happened, and that actually that's why we are deflating the land price, and then we are taking the cross-sectional data for a larger period. So real estate property value is usually estimated using two components, both for structure and land. That means real estate is not only the structure, but also the land price is there. So we can understand structure. By structure we mean the housing options and the features that are being provided, and land means the location and the macroeconomic trends that are that is there in that particular area. So so this is how we can break the models into two parts, right? For example, when we are talking about housing price models, we can have both components for land and also components for the structure or the building. So house price theories were first initiated by Kane and Quigley, and they proposed a hedonic model of house prices in 1970s, and they included the structural characteristics of the housing unit, they included the neighborhood characteristics, and they also considered the distance to CBD. But we can say that with et al. In 1979 was primarily applied Rosen's 1974 theory to develop a hedonic housing price model, and there an accessibility based measure was also introduced. That means he estimated accessibility of a particular land price, and he used PCA to determine those factors which were actually influencing land price. So we will explain that in detail later. So this was the first application of Rosen's theory. And accessibility measures to predict land values and house prices, that basically refers to the location characteristics of that particular land parcel. So when we are talking about house price, we have structure, we have got land, and land is primarily, price of land is guided by its location, and which is again could be determined by the accessibility value for that particular location. So accessibility measured to predict land values and house prices, actually different people have done different kind of assumptions, like people have done monocentric assumption of employment, and then they have said that there is a CBD, people go towards the CBD for their jobs. So that basically it's one a single assumption. Then people have also considered polycentric developments, and they have said distance to multiple employment centers, that has been measured in accessibility. Like in the accessibility lecture, we have discussed measures to determine accessibilities where we have considered accessibility based on employments in different surrounding zones. So that kind of measures could be considered, or it could be a broader concept of accessibility where we consider both potential of opportunities of a location for interaction, which points towards gravity measures. So Noland in 1979 used the accessibility measure where sum of employment across sub areas weighted by inverse of distance. So this is one form of gravity measure. And then Ottensman also used something where he compared several accessibility measures and found that distance and time to multiple employment centers and accessibility perform better than simple distance to center measures. That means instead of using one parameter like distance to CBD from that for that particular plot or that particular house, we can take distance to multiple employment centers, which would give us better estimates. So accessibility becomes a part of the land price model. So hedonic regression analysis is given in this particular form. The price of land or a house at a particular time period can be expressed as a hedonic price function, where P is equal to F, that is function of location, type of land or house, and location could be relative to the urban center, it could be based on the accessibility and so on. Then surrounding means quality of surroundings, the neighborhood characteristics and quality of surrounding area, and then the neighborhood characteristics, which includes facilities, services, crime rates and so on. And these are the different things that has been considered, and the marginal change in any one of these variables result in change in land price called as hedonic price, which is the implicit price or price differential. So that means that if I change any one of these factors, there would be change in the price of land or even in the price of real estate, if we are using this hedonic price function to determine the price of a building as well. So this particular function takes this particular the form actually is like this. If we use we can have linear or nonlinear functions, but if we use a linear function where we use multiple linear regression, again we will explain this in detail, how to do multiple linear regression and how to estimate this parameters like beta 0, beta 1 using this multiple linear regression. We will explain that later, but understand this, that we have this price which is equal to beta 0, which is a coefficient, plus beta 1 LOC plus beta 2 type, beta 3 size. So where beta 1, beta 2, beta 3, beta 4 are all coefficients, and beta 0 is basically the coefficient which takes care of all variables which are not there in the equation, which is unknown to the modeler or unknown to the people who is assessing this. So and these are the variables which are known to us, and we need to estimate what are the coefficient values for a particular area, and this we do by calibrating this particular model using data that we collect using surveys like transaction prices for that particular area. And how to do that, how to interpret the results would be taken up in a different lecture, which would be focused towards multiple linear regression models and so on. Where beta 0 and beta 5 are parameters which measures proportional change in prices resulting from proportional change in characteristics. That means that if I change the value of type, then based on its the value of beta 2, it will have an effect on the total price. So this proportional change in prices resulting from proportional change in characteristics, that is actually captured by this beta parameters. So we can also develop these hedonic models using revealed or stated preference data, and as you can understand, revealed data is the transaction prices. Already the transaction has taken place, and we determine that okay, that was the price of land or building, and what was the characteristics of that particular location, of that particular building, of that neighborhood, and this is revealed preference. Or we can also use a stated preference kind of model, where we ask people that what kind of prices they are willing to pay for a particular land or a particular building. Even though they have not paid it, we can give them options that this is the price which are proposed, are they willing to buy that land or not. So that's a hypothetical measure. So as you can understand, there is difference between actual measures and hypothetical measures. But when we have hypothetical measures, we can give lot of options, lot of choices. So our estimation becomes more robust. So we will again discuss these characteristics in future lectures. So in stated preference model, we use a willingness to pay sort of questionnaire, where a household's willingness to pay to purchase a particular land or price is being determined, and it takes into consideration households having different income and their preferences. That means based on different socioeconomic brackets, we can have different models, or we can include them in the model itself. And the willingness to pay functions looks like this, where P dash is the price people are willing to pay, a particular socioeconomic household belonging to a particular socio-demographic or economic group is willing to pay, and it's a function of size of that particular plot or that house or the location, environment and the building, and also could depend on the income of the household and the preferences based on age, social background and family size. So these are the, even though we have said size, this actually incorporates all the properties of that land and building, and these are the socio-economic properties for that particular household, which we can also see that which kind of household belonging to which socio-economic group has got what kind of effect that those parameters have on the house price or the willingness to pay as well. So we show you some examples. This particular model was developed by Glumac et al. And it's a hedonic urban land price model. We can call it an index as well. And it was based on transaction prices for Luxembourg between 2010 and 2014. We can see the different parameters that has been used in the model. And like there are several accessibility parameters over here: distance to road, distance to motorway, distance to bus station, distance to train station. These are different forms of accessibility. Then another form of accessibility, we can call them accessibility, we can call them proximity. This is like car time to CBD, public transport time to CBD. These are monocentric measures. So even though they have used the term proximity, these are different forms of accessibility actually. Then proximity to cultural amenities, or it could be accessibility to cultural amenities, and then commercial amenities, proximity to border and so on. Then physical characteristics like land plot size, shape of the land plot, is it in a hillshade area and so on. Then environmental characteristics like nearby industry, nearby green space, nearby agriculture, is there a forest nearby and so on. Then legal, physical, economic, this like is it in a highly buildable zone, if the FAR is high in that particular area, is mixed use allowed, if it is within municipal area or not. So here dummy variables has been used. Dummy variables means zeros and ones. That means is it mixed use or not. So we use a 0 or 1, something like that. So there could be also variables on social characteristics of that particular area, like what is the population density, number of percentage of foreigners, percentage of people under 20 years, people under 60. So this could be a retirement community, like more people, percentage of people living above 64 years living in that particular area, and so onward. So this is like so many parameters have been used to determine the price or of a particular piece of land in an urban area. So this is another example. This is the Kane and Quigley paper, where the housing quality was actually measured, and this included survey of approximately 1500 households and dwelling units in the city of St. Louis during the year 1967. So this is the initial paper. So both qualitative variables and quantitative variables were used, and qualitative variables were they started with 39 variables, and then they made them into smaller dimensions using factor analysis. That basically means they grouped those variables into factors. Like for example, these were the qualitative parameters like overall structural condition, general housekeeping, condition of ceilings, condition of walls. So all these were related with dwelling unit. Then parameters related with structure and parcel, like nuisances affecting parcel, trash on parcel, parcel landscaping. Parcel means plot of land, and quality of exteriors and so on. Then adjacent structures and parcel, condition of adjacent structures, adjacent parcels, structural quality of the poorer parcels, then nuisances affecting adjacent properties and so on. And then another group of parameters called block face, where neighborhood problems, percentage of residential land use, percentage of commercial and residential land use, percentage of vacant plots, then trash on block, all these parameters were, then cleanliness, these were all measured. So as you can understand, this cleanliness and this nuisances, these are all qualitative parameters. So there may have been a rating in form of satisfaction ratings, for each condition, the users were asked to rate those values, and then using factor analysis, these were combined into smaller groups of which were actually utilized in the regression model. So each block face or dwelling unit, each was given a particular score, which is a combined score coming out of all these parameters. So that was actually used in the regression model. So we will again explain this factor analysis when we do mode choice model in a different lecture. So in regression analysis, this factor scores for each factor was used, and in addition to that, other quantitative variables were used. And this is the list of those variables. As we can see, these are the factor scores: basic residential quality, dwelling unit quality, quality of proximate properties, non-residential usage, average structural quality. These were the broad factors, and these are the quantitative variables: proportionate of white people in that particular census tract, means a certain zone, median schooling of adults, education level, public school achievement, school quality, and so onwards, age of structure. All these things are the quantitative variables that were used. And then there were other variables which are like what kind of housing. These were sort of dummy variables, like single attached 1 or 0, duplex 1 or 0, row 1 or 0, and so on. And then there were other properties which were more related with rental prices, like no heat included in rent, no water included in rent, like this. Is this inclusive of rental prices and all? Furniture, is it for furnished apartment or not? So here two models have been developed, one for renters and one for owners. So if you see the owner model, the regression models, these are the beta coefficients for each of these variables. So only these variables were considered. When it was for renters, not only these variables, these are the model variables that were considered. So we can develop hedonic regression models both for rental prices as well as for buying prices for that particular houses. So this actually helps us to develop two different models, and because we have these beta values, now we can use those values. Like we take one of the variables, which is number of rooms, which is we take not the direct number of rooms in that house, but the log of number of rooms. Then this was plotted over here, and then we can see that when this number of rooms increases, how the price was increasing. So this kind of graphs could be created, which can also help us to understand when one characteristics change, how the land price or the building price change for that particular area or that particular building or that particular zone. So these are the examples of regression models or hedonic regression models. We will of course calibrate these models, or we will estimate these models using multiple linear regression, which would be taught in details later on. And what we can say is these models assume all individuals have perfect knowledge in regards to purchasing or land or houses. That means they had all information about all houses, all prices. That's why they have chosen that particular house. And that is one. And then data quality is often an issue in land price models, and that means the quality of data that is available that actually determines the quality of the model. Existing market conditions may result in person choosing the next best alternative. That means the one that I want is not available, so I choose because of emergency, I choose the next best alternative. So that may actually give us wrong results when we do a regression. Then multicollinearity of explanatory variables. That means some of the variables that we use may be related with each other, and the model assumes immediate market price adjustment to change in a variable parameter. So that is also broad assumption. So these are the limitations of hedonic regression models. So these are some of the references you can study. So to conclude, land or housing price depends on development and transportation policies and projects in an urban area. That is how accessibility is connected with this. Hedonic regression models are able to predict the effect of these policies. Then land housing price is an important determinant for demand and location choice for residences. commercial and other developments in an urban area. And finally, the effect of demand and supply mismatch on land and housing price is usually taken care of by simulating the land use transportation model for 1 year periods, where prices predicted for 1 year is used to determine real estate development and location choices for the next. So that is how we can make it into a disequilibrium model instead of a long term model of 5 years, 10 years, and then assuming equilibrium. We can actually develop a land use transportation model where we determine this in land prices every year based on the condition, and then take it as an input for the location choice and the real estate developments model in the next time period. That actually helps us to achieve or simulate the disequilibrium conditions to a certain extent. Thank you.